Okay, today's speaker is not a stranger, a well-known character, Mr. Nimal Perera. He's a product of University of Colombo with a BSc in Natural Science in 1983. So you can imagine how experienced he is. Later earned a postgraduate diploma in a pollution control engineering from University of Peradeniya. Industrial engineering from the National Institute of Business Management, NIBM, and a diploma in business and financial administration from the Institute of Chartered Accountants, Sri Lanka. Further, Mr. Perera has gained knowledge on treatment and recycle technology for industrial effluent and waste from Tokai Technology Center, Nagoya, Japan. And also efficient energy use in industry from Luleå University of Technology, Sweden. And also environmental economics from the University of Bath, UK. Mr. Perera is one of the past presidents and a corporate member of the Sri Lanka Energy Managers Association, SLEMA, and a chartered environmental professional of the Institute of Environmental Professionals in Sri Lanka. So Mr. Perera has served local industries for about 30 years, and he currently works as a freelance consultant and also a national expert in the fields of energy, environment, climate change, and sustainable development. Mr. Perera is the president of AccP Forum Sri Lanka, a member of the board of trustees to the Asia Pacific Roundtable on Sustainable Consumption and Production, and a member of the advisory board to the Green State Center of Excellence for Hydrogen in Sri Lanka. Mr. Perera is a member of the SLAB GCGI assessor in the expert team. Also, he is a life member of the Sri Lanka Association for Advancement of Science, SLAS, Institute of Environmental Professionals Sri Lanka, and GHG Management Institute of USA. He is a member of the National Expert Committees to National Climate Change Mitigation Expert Committee, a member of the National Net Zero Roadmap Development Team, the National Energy Award Evaluation Panel, and the Presidential Environmental Awards Evaluation Panel. Mr. Perera is a member of the UNFCCC National Roster of Experts for the National GHG Inventory Development. Of course, GHG is greenhouse gases. So Mr. Nimal Perera was recognized with Special Award, Environmental Achievement Award, by the United States Asia Environmental Partnership Program, USAEP, in 2006. I think he's the most suitable person to deliver this lecture. So Mr. Perera, floor is yours.
Thank you, Mr. Dalugoda. Thank you, Chandana, for the kind introduction. Give me a couple of seconds until
let me go
share my presentation. Okay. Hope everybody can see my presentation.
Yes, sir, we can see.
Okay. The topic today, which I'm going to discuss with you briefly, this is a very vast subject, though it's a very wide subject area, but I will try to limit my presentation to a very pertinent areas, like speaking about the green hydrogen and its versatility or as a versatile element in national green economy. When I say the versatile, it is it's a multifunctional. So what are these multifunctional impacts which we can talk about with this particular subject called green hydrogen? Uh, Before jumping into green hydrogen, I will give you a very briefing about the net zero and the green, because I am going to discuss with you all about the greening subject. So some people, they are talking about the net zero. Some people, they are talking about the greening. Of course, the greening is a very wide subject area. And then greening is a broad transformation process toward the sustainability. But of course, this net zero is only a small portion of it. So therefore, you can think net zero as one goal within the larger process of greening. So therefore, let's talk about the greening with some aspect of the net zero as well. So here, now, what is this net zero? I'm sure that most of you all are very much familiar. If you all are talking about the climate aspects, the amount of carbon dioxide which we are emitting by the humans' activities or the anthropogenic activities, how much we are emitting, and at the same time, if we can either reduce or absorb the same amount of carbon dioxide back to the system. If we when I talk about the system, I'm talking about the human system we are living in this living atmosphere. If we can through all our activities, maybe industrial activities, if we can, especially the industrial activities where the humans are putting their pressure or putting their, efforts to make more and more economic development. And through all these activities, if we can reabsorb back all the amounts of carbon dioxide emitted to the environment, and that is we can define it as a what you call a balanced condition. So that balanced condition is named as net zero. Why we are talking about this net zero? Because according to the Paris Agreement, which related to the climate change sector, so you can see how the global carbon dioxide levels and especially there is no any carbon dioxide concentration given here, but you can see the global temperature increase from the pre-industrial era, that is from 1850. The Paris Agreement, we are hoping to limit the temperature increase to a 1.5 degrees Celsius, which is relevant to the pre-industrial era. But you can see 2024, where we already passed that year. During that year, we have already surpassed 1.6. So that is a very dangerous part of this climate change. Though we are talking about the climate aspects, everything, but we are at a very detrimental point in terms of the climate change, because the the temperature around us has gone beyond 1.5 pre-industrial era limits, average limits. So, but still we are keeping some hopes, nothing else, especially on the green hydrogen. Of course, according to the official figures, 2024 was the highest temperature ever recorded in the history, in the current civilization. According to my knowledge, I could remember in 2024 we were hearing that the highest temperature was recorded in 2023. Similarly, in 2025, end of the 2025, we will, or maybe in the next year, we will hear the same thing. 2025 was the highest temperature ever recorded. So the final thing is continuously this one is keep on increasing. So my I'm trying to give you a kind of discuss a kind of solution for this one is basically nothing other than this green hydrogen. When you talk about the hydrogen, I don't want to take much more time to explain about hydrogen. Hydrogen is the lightest atom in the periodic table. You can see there, which we learn in our O levels, A levels, and even the lower classes. And the first recognized by the Henry Cavendish in 1766 and so on. There are so many stories behind hydrogen, but the hydrogen, when you talk about hydrogen, it has three isotopes, namely protium, deuterium, and tritium. Especially the deuterium and tritium, they are isotopes of hydrogen, all isotopes, but we are very much keen on this subject called protium. And when we are talking about the hydrogen, now we are talking about a very spectrum of hydrogen, starting from green hydrogen, purple hydrogen, yellow hydrogen, blue, turquoise hydrogen, or maybe gray hydrogen, brown hydrogen, or maybe even black hydrogen. What are all these? Especially when we are talking about the hydrogen, we are very much interested about the green hydrogen, purple hydrogen, and the yellow hydrogen because they are produced by the process called electrolysis using electricity. Of course, we were using this gray hydrogen and brown, especially the gray hydrogen, even in Sri Lanka. Currently, we are using several tons of gray hydrogen for industrial purposes. Long time back in the history, we were using this hydrogen, gray hydrogen, especially to manufacture fertilizer, especially the urea in the country. But of course, due to several economic reasons, that has been closed. But now we are highly focusing on this green hydrogen, which produce using wind, solar, hydro, geothermal like renewable energies. And using these energy sources, we are splitting or electrolyzing the water and generating hydrogen. This is called green hydrogen. Of course, the electrolysis can use the nuclear energy as well as the mixed origin energies in the grid, which respectively we can address them as purple energy or yellow hydrogen. And then why we are talking so much about this hydrogen? Now, if you refer to this table, you can see there are different types of fuels, starting from hydrogen, methane, methanol. Methane is basically, we can say, the natural gas, methanol-like gases. All these fuel types are having a lower energy calorific value than the hydrogen. So that is one factor. And on the other hand, green hydrogen is clean. It means zero carbon emission is happening if you burn this particular fuel. And in the meantime, if you go through the flame temperatures of this particular fuels, methane, acetylene, carbon monoxide, with different volumes of air, we can see hydrogen is having one of the highest flame temperature, that is about 2400 Kelvin. So that has a value. So therefore, we can think about that particular the hydrogen. If we can produce this hydrogen without or with the minimal impact to the environment, so that would be considered as one of the best solutions. And then we are talking about the hydrogen. Now, if you refer to this table, you can see there are different types of fuels, starting from hydrogen, methane, methanol, methane is basically, we can say, the natural gas, methanol-like gases. All these fuel types are having a lower energy calorific value than the hydrogen. So that is one factor. And the other hand, green hydrogen is clean. It means zero carbon emission is happening if you burn this particular best source for our economic development. How? But if you go through the historical the evidences, you can remember we were using this in our school days or in our child time when we were child. We used to use some caustic soda and aluminium foils to generate hydrogen, which is called chemical hydrogen, and fill into the balloons and float it. So that's what we know in the history. But other than that, there are several usages of fuel, like we are currently, most of the spacecraft, they are using this hydrogen, especially the liquid hydrogen as a fuel. And in certain cases, we are using as a welding fuel, nitrogen fertilizer, food industry, and wide spectrum of usages we can today discuss, including the power sector. We name normally hydrogen is it is not a source of energy. It is a energy vector, but you can use hydrogen as a for the purpose of energy storage. So that is very important factor. And also this hydrogen we can use as a fuel through the direct combustion types in the direct combustion engines. Especially Toyota is now taking the priority of this particular technology. And also hydrogen we can use as a fuel through the fuel cell applications. What is basically happening? Hydrogen we are supplying to the fuel cell. It is the reverse of the electrolyzer, and it produces uh, electricity, and they are using that electricity, we can drive the vehicle. And maybe for various cryogenic purposes and various metal treatments, and also in the oil refineries, we are using hydrogen. So then, hydrogen, green hydrogen, and renewable energy, they are linked together, right? Only we can produce green hydrogen with the supply of green energy or the renewable energy. So that is a most important thing always we have to keep in mind. The green hydrogen is defined as hydrogen produced by splitting water into hydrogen and oxygen using renewable electricity through a process called electrolysis. So that's the most important definition about the green hydrogen. And of course, if you think about the global carbon dioxide emissions, nearly about 74% of the emissions are coming out from due to the energy use in the industry, or maybe domestic, or maybe in the transport sector. Altogether, there is a summation about 73.2%. Now, if we can make a mechanism to reduce this amount, to nullify this energy use and its resulting carbon dioxide emission, the main source of this energy sector that responsible for this 73.2% energy use is the fossil fuel, because we have to burn fossil fuels and we have to use that energy. So if we can find a mechanism to replace this particular fossil fuels from this particular source of energy, definitely we can reduce this amount of emissions in the environment. We have a result, we have a very useful kind of a resource. It is nothing other than renewable energy. But the problem is the renewable energy like solar, wind, like energies, so they are intermittent. So sometimes you can capture the energy, but sometimes you can the source is not available. So in that case, how we are going to supply it? So that's the question. But if we put your mind to the diagram in the right-hand side, you can see the amount of the renewable energy potential in this world. It is huge when you compare to all the other non-renewable energy sources. Having that idea in our minds, so we will think about what is this versatility of green hydrogen. Rather than green hydrogen, first we will think about the green or the grid renewable energy. Because we are capturing energy, the renewable energy through solar or wind or other sources, and then we are feeding it to the national grid. So the national grid, we can connect it to various industries, transport sector, or maybe domestic sector. We can use it only for the purpose of uh, electricity or the power supply, if we have that scope. But in the meantime, we are very seriously talking about the renewable energy storages with batteries. Batteries, for what purpose we can use? Maybe for transport, or maybe grid balancing, or maybe even sometimes for very narrow purposes, but not for very strong. Maybe for as a backup source, we can use these batteries. These batteries charge with the renewable energy. On the other hand, we can think of, though it's not mentioned here, we are talking we are talking the subject called the pump storages. When there is a excess amount of renewable energy in the grid, we can use that excess amount of additional amount of energy to pump the water from lower levels to the upper levels, and the grid balancing and the storage we can do with this pump storages as well. But for what purpose ultimately we can use this energy? Only for the purpose of powering the nation. But if we can if we can apply this added electricity or additional electricity through electrolysis, and if we can do a generation of green hydrogen, then we have number of purposes like grid balancing, marine transport, steel production, glass production, porcelain, fertilizer, aviation. Likewise, there are a number of processes we can address about. So therefore, it's worthwhile to talk about green hydrogen. So that's why I have already said this is a very versatile element. The renewable energy is intermittent, as I mentioned earlier, solar and wind power generation. I'm sure that you could remember the dark experiences we had in our country because of the grid imbalance situation. So all these things are reasonably could be addressed with this particular subject called green hydrogen generation. This variability can ultimately create, frequency or voltage instabilities, grid congestions, curtailment. Sometimes we have to curtail the generation. Maybe that's why the utility sometimes they said switch off all the rooftops, or maybe the power generation, the renewable power generation or the solar power generation systems during a particular period. So if we are ready with this particular green hydrogen generation facilities and the electrolyzer system, definitely we could have used this particular mechanism to generate green hydrogen. And of course, this could have been used for further powering the nation back again, to generate the power, and at the same time used for various other multi-purposes which we can discuss in my next slides. So national power grid balancing is normally the subject which is connected with the electrolyzers and the green hydrogen and renewable energy, which I'm not going to give you much more elaborated explanation because I'm sure that you have already received some kind of understanding. The real world application, somebody would ask me, are any other countries, they are using this electrolysis mechanism and green hydrogen generation as for the purpose of grid balancing? Yes. In fact, I have already visited one of these places in Germany. I saw how they are balancing their grid at higher levels of renewable generations. When there is a higher levels of renewable additions to the national grid in Germany, especially in the northern grids of northern side grid of Germany, they start their electrolyzers and they generate green hydrogen. That green hydrogen again they capture and mix with their natural gas grid or natural gas pipelines. With that, they increase the calorific value of this particular energy source, that is the thermal source, and they receive the benefit. In the meantime, they are not curtailing the absorption of the renewables to the national grid. And of course, it's happening in Japan, Australia as well. In the meantime, the application of electrolysis for Sri Lankan national grid. You would ask me a question whether can we do it? Yes. We have already done some preliminary studies, and even we have done some preliminary studies where we can join, where we can connect these electrolyzers. The places like Begum substation, Chunakam and the Kilnochi grid substation. They are very preliminary studies we have done yet, but not the detailed studies already not have been done. But with the detailed studies, technical and the economic studies, we can move ahead and decide where we are going to mix this, connect this grid balancing equipment for the electrolyzers. But we have to consider the following aspects when we are before go for this implementation. The grid capacity, we have to have some idea whether the infrastructure ensure it handles the additional loads from the electrolyzer, because when we connect the electrolyzer, there may be additional loads. And of course, we have to think about the water availability, because water is one of the critical factors when we are talking about the electrolysis. There should be fairly reasonably clean water sources. And of course, if you don't have, you have to generate clean water, maybe different processes. The renewable source assessment, conduct detailed studies to match the electrolyzer capacity, and regulatory framework. Of course, that is the policy framework is a must to have this sort of operation in Sri Lanka. And of course, the power to gas. The power to gas surplus renewable electricity, where you are going to use it. Either we are going to store it for a long time, whether though we don't have a natural gas grid, but hope at least by 2028 or 2030, we will have a limited natural gas grids. So are we going to, where we are going to mix this particular hydrogen? Or are we going to convert back to electricity in fuel cells or maybe turbines where we are going to use it? The potential site for pilot operations, of course, the Sobadanavi 350 megawatts combined cycle power plant we can use even it is available at the moment. And then the green hydrogen in transport industry. There are two technologies we can think about, either through the combustion technology or maybe fuel cell technology. Fuel cell technology is it has a very long history. Even I could remember in 2013 or maybe 2012, I had the experience to travel in a fuel cell operated bus in Korea. So during that time, even they were they were on research on this particular subject. And what are the key transport sectors we can focus on this coupled with the green hydrogen high potential? The heavy-duty transport sector, of course, definitely it has a very assured opportunities to use green hydrogen, especially trucks, buses, long-haul, the freight transport system. Why we are so much interested about this hydrogen? When you compare with the battery technology, it has a very fast refueling than battery electric vehicle. And the range is nearly about 1,000 kilometers when you compare with the battery technologies. And also, if you take the weight of the battery bank and the hydrogen storage tank, of course, it has a very light weight. In several countries like Hyundai in Europe, Toyota, and then number of industries, they have already come to the scene with their technologies to use green hydrogen in their automotive systems. One of the two, the leading organizations are Hyundai and Toyota. Earlier, Toyota was promoting the fuel cell operated vehicles, even cars like Mirai, brand called Mirai. But they have stopped this promotion of this one, and then now they are very seriously planning to, they are working on producing internal combustion-based hydrogen vehicle, which will be a very serious threat to the battery technology as well. So what are the potential countries like Sri Lanka? The moderate to high or long distance cargo planes, or maybe intercity buses, once the hydrogen or the green hydrogen infrastructure is available. According to the national hydrogen roadmap we developed in Sri Lanka, we have already planned a pilot bus operation from Colombo to Jaffna as a pilot operational fleet. And of course, in the trains also, this is very feasible. Hope you could remember in a long time back, in 2009 or somewhere, one of the French company, they have already introduced the train called Podia Island hydrogen powered train operating in Germany, France, and Italy. Of course, in Germany, the system has already stopped because of several reasons. One reason was it was costly, and the other one was unavailability of the supply chain. But now they are again planning to bring the operation back with the improvement of their supply chain, and of course, now very rapidly. Hope you could remember when the solar panels were introduced to the market. They were very expensive, but now they are very cheap. Similarly, the electrolyzers also becoming very cheaper in the market rapidly. For Sri Lanka, the bus fleet would use hydrogen, especially in air polluted areas like Colombo. Of course, this has a very high potential in the maritime transport as well. There are a number of countries already uh, started their pilot projects and some commercial operations as well. It is a very good source for, on one hand, economic mode of transport. In the other side, it is a very good source for decarbonization in the transport industry. In Japan, especially, they have already started commercial projects with hydrogen-based maritime transport. Even in Sri Lanka, we have a lot of opportunities, especially the hydrogen-powered harbor craft, tugs or maybe green ports. Now, if you can think about if we could convert our harbor operation to a green fleet of ships or the maritime operation, maritime equipment, what sort of green service we can offer to our ships, all the ships coming from various parts of the world, especially the ships from shipping fleets from the European side. They are very seriously looking for green supply systems to operate their maritime fleets. Therefore, we have a lot of opportunities in the maritime sector. Aviation, of course, mostly uh, they are on the pilot stages, but the various aircraft operators they are in the phase of pilot operations, and they are very soon will start rolling their systems. Most likely by post 2023, after 2023, there will be uh, flights operating with green hydrogen. So if you do a very simple technological comparison, hydrogen versus battery, because I was talking about the batteries and hydrogen, the factor like the refueling time in hydrogen is in the range of minutes, but battery electric charging may be about hours. The range in between 1,000 kilometers and maybe about 600 or maybe 500 kilometers per charge. And then the weight impact is very small in the case of hydrogen compared to the heavy battery pack weight in the battery electric equipment. The infrastructure is emerging, especially for the hydrogen. It's in the pipeline, but most of the infrastructure for battery electrics are being already developed. Though it is not very much available in Sri Lanka, the other countries it's available. The efficiency is nearly about 40 to 60% in the case of hydrogen through fuel cell operation. Battery electric, it will be 80 to 90. But now slowly and steadily, this efficiency is improving in the hydrogen sector as well. Especially hydrogen systems are very suitable for long hauling or maybe heavy duty, and battery electrics are better for urbans and the light duty automobiles or the vehicles. What are the potentials for Sri Lanka? Of course, in the long distance trucks like container carriers, The potential is very high. So condition is what we have developed is need to hydrogen stations. We have to start promoting of generation of green hydrogen and also establishing hydrogen stage supply station at least next to the main corridors. Intercity public buses, uh, the potential is very high with this hydrogen. But like three-wheelers or tuk-tuks or maybe taxis, the potential is very low. So battery electric vehicles are the best for the small vehicles like two-wheelers or maybe three-wheelers. Shipping, handling for the shipping from the ports, medium, it has a medium potential. The rail, it's low to medium potential. And aviation, of course, it's a long-term story which we have to go for a long period to study. And of course, we were dreaming about this railway electrification for the last number of years, according to my mind, from 1970. We are planning to go for railway electrification. But still, we have not developed at least a 1 kilometer or at least a 1 meter with electrified railway. So during the electrification process, we have to go for three areas. We have to consider we have two potentials, either overhead electrification or maybe the application of third rail, as given in the right-hand diagram, the picture. But both cases are, first one is a little bit costly for Sri Lanka. The other one is basically not very social friendly. So it's worth to make a kind of a R&D process, launch a R&D process, converting at least to existing locomotives to hydrogen power. It's a good area which we can think about. Metal industry, like steel production. Though we don't have the primary steel production from steel or the iron ore to the steel, we don't have the industry here. But we have the secondary metal processing or steel processing, which we can think about as a source of heat. We can think about hydrogen. And then there are proven operations in the world, Sweden, and also in Germany. They have already come up with proven results to produce steel with green hydrogen. And then the glass manufacturing. As you all know, the glass furnace, normally when you produce the glass bottles or any other item, you have to achieve the temperature around 1400, 1600 degrees Celsius in their furnaces. The hydrogen can fully or partially replace natural gas or maybe other sources to oxyfuel these furnaces. In simple words, using green hydrogen, we can achieve these temperatures. Of course, there are certain challenges, like hydrogen has a different combustion properties than the other fuels. So therefore, you have to think about what are the other repercussions coming along with this particular fuel. But still, there are possibilities to use the green hydrogen in these industries, and the decarbonization is possible. And in the meantime, if we can go for production of low-cost green hydrogen, so that would be the best opportunity for this particular industry. So these are some of the cases already proven the use of hydrogen in the glass industries, or maybe even operating at a pilot scale. According to the information, the vodka packing bottle, the vodka bottles already, they have converted the system, the manufacturing system, not the liquid, not the alcohol, but the glass bottle, they are producing using green hydrogen. And there are certain technical considerations like flame temperatures. Of course, when you burn hydrogen, it will automatically generate NOx, or the NOx emissions also will be there because of the high temperature combustion. And the energy density of the particular the element called green hydrogen has to be taken into account because it has a lower by volume, may require more fuel inputs to improve the burners. So therefore, in these cases, the glass, either glass or maybe steel or whatever the commodity, you have to take special precautions or the research and development before getting into this operation. The redesigning of this particular gas burners used in the current industries currently. So therefore, when you're retrofitting from one to the other, especially retrofitting from fossil fuels to the other cases, we have to be very careful. We have to maybe think about the furnace lining also because of the temperature and the other changes. Cement industry is also another particular area which we can think about, which needs again some level of certain level of R&D. But these are because always when I talk about, you could remember I was talking about the R&D. So these are the best R&Ds where the students can undertake in lab scale, but with the possibility of extending to the commercial scale productions in the country. So in the cement industry, there are possibilities. If we can think about the green cement in the future, so that will be the best opportunity for Sri Lanka. Sri Lanka cement industry could explore hydrogen to reduce the dependence on imported fossil fuels, because currently we are heavily depending on fossil fuels, especially we have only one composite for cement factory in Sri Lanka currently. At least that one, if we can switch from it's operating on coal, we can switch from coal to green hydrogen, that will be a great achievement. Aligned with the green industrial development and carbon market mechanisms, again, there will be added benefits. They integrate with the renewable energy growth, especially the solar and electrolysis for local hydrogen production, rather than centralized. If we can think about the localized or decentralized hydrogen production, is also one area we can think about. Position for green cement, that's what I have already explained. If you can think about the green cement with the green buildings, that would be a very top advantage for the country. And of course, the industry heavily depends on the fossil fuels, either porcelain and the ceramic or the tile industry. They are using huge amounts of fossil fuel because they have to achieve sometimes the temperatures of 1200 or maybe 1,400 degrees Celsius, where they are currently mostly they are obtaining from fossil fuels like LPG, or maybe even kerosene, or maybe industrial uh, diesel, etc. So therefore, if those kilns and the high temperature the kilns and the furnaces, if they can switch to hydrogen, or at least starting from the blending level, rather than just retrofitting from A to B, why can't we think about starting with small percentages of blending with green hydrogen, and then slowly increasing uh, the uh, the blended percentage of hydrogen, which will have a substantial benefit in decarbonizing as well as the economic benefit. But of course, we have to get ready with the green hydrogen supply chains. So the supply chains have to be get ready before jumping into these technologies. As I mentioned, Sri Lanka has a very significant export industry, export benefits from this particular industry. Because I have been to a number of these porcelain industries in Sri Lanka. They are suffering mainly because of the heavy fuel cost, as well as the export barriers. Sometimes they are uh, having in front of their marketing chains, supply chain, because of the brown nature of this particular the products, because they are using huge amount of fossil fuels, and already the carbon footprint connected with these particular products are very high. Of course, if we can start thinking very seriously on this subject, retrofitting or maybe partial replacement of fossil fuel with green hydrogen, because the green hydrogen production is the main the what we are the what we are looking, the raw material is mainly from the renewable energy. The feedstock is basically uh, renewable energy. It's amply available in our country. Only thing is we have to plan it very well, where we have to generate, how we have to collect it, how we have to store it, how we have to distribute it, and where to use this particular valuable commodity. Of course, in the fertilizer industry, especially the urea manufacturing, nitrogen fertilizer manufacturing industry, uh, hydrogen is one of the key elements. You have to produce ammonia before you produce urea. In the conventional urea manufacturing process, what we do is the Haber-Bosch process. What we do is first we produce gray hydrogen by splitting maybe the naphtha or any other hydrocarbon, or maybe natural gas, and then produce hydrogen. And then it has a carbon footprint, high carbon footprint, and then mix up with the atmospheric nitrogen to produce ammonia through the Haber-Bosch process, and then mixing again, amalgamating with carbon dioxide to produce uh, urea. So that's the basic process, conventional process. But if we can replace, it's already been done. It's already been practiced in certain industries, like one of the leading urea manufacturers, the fertilizer manufacturers in the world is called Yara from Norway. They have already come up with the process uh, beyond the pilot scale to produce uh, green urea with green ammonia, green hydrogen and green ammonia. Of course, if you produce green ammonia, it has another value. Very easily you can liquefy it, and then you can transport from one location to the other. Partly you can use the green ammonia as a feedstock for fertilizer. At the same time, you can use as a marine fuel. So these some of the a basic calculation which I did, potential economic benefits to Sri Lanka. The estimated total economic benefits to Sri Lanka from fully implementing green hydrogen economy that involves several assumptions. But it's not very within a short period. I made this calculation with several assumptions and projections across sectors like energy, transport, export, and other cases. These are some of the benefits which we can expected to Sri Lankan economy in US dollars per annum, especially in the fertilizer industry, right? Job creation, green fertilizer, fertilizer import cost saving, health and environmental benefits, and then again avoid carbon dioxide emission cost and everything put together. You can think about a substantial cost saving or maybe a foreign exchange saving to Sri Lanka with the green hydrogen. Of course, I would say it's not 100% accurate figures because I have made a lot of assumptions, but these are some of the, this could be a kind of a seed for students to start maybe researching R&D in their projects, through their projects, to come out with a good figure, what would to and give out to the figure to the country, what would be the best economic benefit which we can expecting from this particular subject. And of course, this is again a similar study, estimated economic benefit from green hydrogen to Sri Lanka, export revenue, fossil fuel import saving, job creation, industrial productivity. Likewise, I have made some the very reasonable assumptions, economic benefit with certain key assumptions. I'm not going to go through each of these because of the time limitation. And other industries like oil refineries, currently we are using in oil refinery and food industry. Semiconductor production still it's not happening in Sri Lanka, but there are potentials to use green hydrogen in these industries as well. According to the diagram which I obtained from the Greenstat, they did this presentation for the business community in Sri Lanka. These are the potential to Sri Lanka's most competitive energy hub. Because if we go for a green energy hub or develop a green energy hub in Sri Lanka, with the addition of the estimated capacities like solar 16 gigawatts, wind about 40 gigawatts, and pump hydro and biomass, everything, we can think about a very good or stabilized power grid. In the meantime, we can plan for a set of microgrids, either on-grid or off-grid. In the meantime, with water, with the input of water, we can split this water and then deliver hydrogen. We can think about exporting of hydrogen or maybe derivatives of hydrogen like ammonia to the region or maybe to the world. But the challenges still we have not planned for. At least we don't have a green hydrogen policy in the country, according to the information what I heard. It's been already prepared, it's in the draft stage. Once I was talking about this green hydrogen, one young fellow told me, sir, we are now the world is very seriously talking about green hydrogen. The countries around us, India, Pakistan, Bangladesh, like countries, they are talking about green hydrogen very serious. But still, we couldn't brought a source of uh, natural gas to the country to operate our low-cost operation of our power plants. Since 2006, we are talking about natural gas, but still we couldn't make it a reality. And then green hydrogen depends on the electrolysis, renewable energy. Of course, the technology is available. The water is, of course, available with certain purification needs. Distribution and refueling infrastructure to be developed. Still, the cost of the green hydrogen about 2 to 5 times of the cost of diesel or electricity as of 2025. But the rates are very rapidly falling. Maybe about a couple of years back, this was around 3 to 6 times, but now it has come down very rapidly. In the meantime, the electrolysis efficiency was a kind of a challenge in the past, but now uh, even 95% or 85% efficiency, 95 efficiency like to produce 1 kilogram of green hydrogen, only we have to provide 41.5 kilowatt hours. So that sort of efficiency is now available even at the commercial level. Countries like China, Saudi Arabia, Germany, India, Australia, then USA, United Kingdom, France, Netherlands, Spain. So they are the top leaders of this green hydrogen race. But we have already done a minute amount of the Sri Lanka in 2023 National Green Hydrogen Roadmap outlines a strategic vision to leverage its vast renewable energy resources, including offshore wind and solar, to establish a green hydrogen economy. So this was done with the support of the Norwegian government and the Norwegian organization called GreenStat. The roadmap emphasized the dual objectives of achieving energy security and becoming a regional hub. So this is also part of the GreenStat and the Sri Lankan national work together. Few essential extracts of the Sri Lanka Hydrogen 2030 roadmaps I have highlighted here. Creation of 4,000 employment, earning about nearly 500 million from the export related to the green energy value chains. So likewise, substantially valued outcomes are being already planned with this particular roadmap developed by the GreenStat and the Petroleum Development Authority in 2023. Finally, while we are talking about the green hydrogen and the operations, the first ever green hydrogen based rather than green hydrogen based gas turbine ready to operate in Sri Lanka at Sabadana power plant. Actually speaking, this photograph I have taken today from one of the poster on their walls. They are next to their operational control room. In this particular Sobadanavi 350 megawatts power plant, it's a combined cycle power plant. The main turbine has a capacity to absorb or blended natural gas and hydrogen together at the rate of 30% hydrogen. So if we produce green hydrogen, very easily we can blend with, directly we can blend with the natural gas in this particular gas turbine. We can produce partially green power. Problem is, still we don't have natural gas. If we operate this particular power plant with the supply of natural gas, of course, the unit will be cost around 20 rupees per kilowatt hour. But currently, as we don't have the infrastructure or the supply sources, which we are hoping to receive by 2028, I believe it won't be a dream again. Currently, we are operating this particular power plant intermittently with diesel. It's not a fault of this particular organization. The planning for this particular commodity has to be done by the government. According to the sources, they have planned by 2028 to available the natural gas in the country. Then, in the meantime, if we start producing green hydrogen in the country at different levels, both will be available. At least we can partially green electricity in the grid with this particular equipment. I would like to end my presentation with an extract from Jules Verne in his Mysterious Island write-up in 1874. He wrote, I believe that water will one day be employed as a fuel. Water will be the coal for future. So the idea was expressed in 1874, nearly about 150 years ago, showing Jules Verne's visionary grasp of science and energy possibilities. Thank you very much for your listening. I will end up my session with this quote and open for question and answers. Thank you very much. Over to you, Chandana.
Thank you very much, Nimal. It is a fantastic lecture, a timely topic, and a wonderful explanations. So, question and answer session is open. We'll see anything on the chat box, or anybody can speak. Any questions?
So I have a question.
Please go ahead.
Actually, two questions. My first question is, when the economic benefits of green energy or green hydrogen is obvious, why does the government insist on fossil fuel, like not promote? There's no subsidies for like EV cars. Is it because IMF still insists, or is it because the government want quick revenue on fossil fuel? That's question number one. Question number two is, why did they plan on a Subodh Navi green turbine when obviously there was no natural gas or green hydrogen available in the country? Thank you.
Nimal?
Okay. Second question I can answer immediately, though I am not a partner of the Subhadanavi for the Lagdanavi group. What I could understand is it's a part of the long-term generation expansion plan in Sri Lanka. So therefore, it has been developed with the hope of hope you could remember during last couple of years, we had several discussions went on to about the natural gas subject. But I don't want to explain you the lethargic situation in the country because of the socio-political or maybe different the reasons. Because of all these reasons, delay. Otherwise, if we start planning, at least, so I could remember we had the first the seminar or a kind of annual session in our Sri Lanka Energy Managers Session annual session, either in 2003 or 4. The introducing this subject called the use of natural gas in the power sector. Since then, several campaigns were happening. When all the other our peripheral countries they were planning for natural gas, we were trying to go behind coal or other sources. So several reasons I can come up with, but anyway, the result was we couldn't have our low cost energy, low cost and reasonably green energy compared to coal. That is one. What is the other question, Chandana, you raised? I could remember.
You answered for the second one, is it?
Yeah.
The other first one was why not government give subsidies?
Why does the government still persist on fossil fuel for transport sector, like and not promote or subsidies for EV cars and things like that on green energy? Is it because IMF insists on fossil fuel, or is it because the government wants quick revenue for short-term financing?
I cannot give you a clear answer for this one because the current government regime, the way they are thinking is not the exact the way what the previous regimes were planning about. So I am not very much familiar with how and what they are, but still though different people they are coming up with different opinions. What I feel is the current government is having some kind of a renewable energy promotional platform or a kind of vision. We hope for the best. So that's the only thing I can come up with.
Right. Now I will take, yeah, go ahead. Okay, thank you very much. So we'll take chat box questions. Suprata Chandrasekharan, you are asking, can you please suggest few documents on the pilot project outcomes in the substation mentioned above?
Mainly, I referred some of the archive documents from universities. They have come up with these particular research projects. If you visit to various universities, especially University of Moderator and Peradeniya, these research projects are available. So from the archives, you can find them.
Thank you. The second one is from Muskan. What role are Indian companies and research institutions playing in the advancement of green hydrogen technologies in 2025?
What role are Indian companies and research institutions playing in the advancement of green hydrogen technologies in 2025? Of course, according to my knowledge, the from Indian side, they have gone far ahead than Sri Lanka in this research needs. I could remember when I had discussions with some of their research institutes, they have gone very far ahead than us. And in the meantime, the government policy has given them the kind of a substrate to come up with the realities of these particular research areas, which is not happened in Sri Lanka. One of the pathetic, kind of a situation. So that's why now if you go to the Indian industry, now they are planning very much ahead to get the success stories of green hydrogen than Sri Lanka. That's what I have to quote.
Thank you. The next one, of course, name is not given. How important will it be to have a regulatory framework for green hydrogen development in Sri Lanka?
It's a very top requirement because unless otherwise you have a regulatory framework, especially number one is normally when we are introducing a kind of of course, we have done with the support of the Greenstat India and other the Sri Lankan agency, the what you call Petroleum Development Authority. They have developed this roadmap, but what I think is before the roadmap, we had to have the what you call the policy. If we had the policy and then the action plan and the roadmap together, then we would have. In the meantime, the policy framework, if it was there to grab the potentials of green hydrogen together, we would have been gone far ahead than what we are suffering today. But it hasn't been happened. So at least we believe at least with the current situation, we believe it will happen today. Positively happen today for the next generation in the country.
Thank you. Next one is from Sadhuni Vimansa. There are gap between green hydrogen technology theories and practice in the real world. What are the reasons for it and what can we do for communicate this to the Sri Lankan community?
Of course there are, because though I preach this green hydrogen technology, still there are a lot of gaps which we need to cover up with wide spectrum of the research and development work in the country. So that's why I have chosen this subject to talk today, especially to speak to the young generation, university students, not just to do a kind of a research with the purpose of having your degree. It has to be a kind of a fruitful one which we can develop to the commercial level with the real understanding of the economics of the particular project. So in that case, don't limit it to the basic economics, but I would say I would prefer if you can limit the research work to the sustainomics or the sustainable economics, which is a must today when you are addressing a project or research today. But today, mostly we are thinking there is nothing called environmental economics when we are doing any study for any particular case or research. So therefore, you have to have a wide approach with all these elements of the sustainomics or the sustainable economics of that including the real economics of the project with the proposed research program.
Well, there are no any other questions. So I thought I would ask a little question, a layman's view. While accepting the fact that the future is green hydrogen, yes. But on the other hand, to produce 1 kilogram of hydrogen, we need 9 kilogram of water. Now, when it commercialized, and it will be the a product, then in the current terms, the scarcity of water, won't we have to, see whether the seawater can be used for this kind of a thing? What is your idea?
Yeah, currently there are top research is being done already to use the seawater for the green hydrogen production. There are two parts. One is the improving the research activities to achieve green hydrogen with seawater directly, or maybe purification of green hydrogen, purification of seawater with through the process like RO process like or reverse osmosis, and then use the purified water for this electrolysis. So these are the two parts. The second one is a little bit costly, but of course with the low cost approaches of what you call the renewable energy, it won't be a brain. What I believe.
Thank you. Thank you. I think, is there any questions? Okay, we'll wrap up, and this is a wonderful lecture. I hope all the people who listened, and even our responsible government agencies will see the advantage of green hydrogen after this lecture. Thank you very much, Mr. Nimal Perera.
Thank you, Chandana. Especially I conduct this.
Chandana, on behalf of the Green Building Council, I wish to thank
Yes.
Nimal for.
Yeah. No, give me a second. Actually, I speak very especially. I try to address this through this presentation. I try to address to the student community. So especially they are the people who have to take the burden of this country in the future. So what we could do is basically making a direction for them a sustainable direction for them. So therefore, please take the direction of sustainability, the sustainable path of this country, and try to make a sustainable and green country in the future. Thank you very much.
Green Building Council Chairman, Mr. Architect Chandana Perera, please have a word. Okay, right.
Thank you.
will
Yes,
wind
sir.
up.
Thank you, sir. Thank you very much, Moderator Engineer Chandana Dalugoda and Mr. Nimal Perera for your enlightening presentation and knowledge gathering and knowledge sharing with us today. And sincere thanks to all participants for joining us today as we mark Environmental Week with knowledge and action. We hope today's session had sparked new ideas and deepened your understanding of the green hydrogen revolution and its relevance to our national sustainability goals. Don't forget to follow us on social media and stay tuned for more events and green talks by the Green Building Council of Sri Lanka. Let's continue working together for a cleaner and greener future. Thank you so much.